Hello, hello. Okay, I'm audible. So, hello guys. After a long time, I am back on my channel. Okay, so what we have today, we are discussing target DSA T4 contest, which was OA style. So, without wasting much time, let's get started with the problem one. Yeah, many of you were asking in feedback form to like about the questions. So, let me tell you firstly that the question match discount one. This is original D show OA question. And the second problem is for optimal gains. This is a Google OA question. It was asked in my set only. It was problem two, I guess, at that time. The third question, the tree question, the question based on tree, that question is also from Google OA. And the last question is also from D show OA. Okay, so let's get started with the problem one. So a service provider is providing offers on n services, but they will use logical or instead of plus operator for calculating the total discount. Okay, basically, what we are given in this problem is we are having n services, and for each service, we are given discount array. Basically, for each services, we are having a discount of I. Okay, and the total discount of all the services is not summation of discount of I. According to this problem, the total discount is basically the bitwise OR of all the discount values, right? Basically, the total discount is D0 or D1 goes on till D of n minus 1. That's how you are calculating the total discount in this problem. Okay. What we need to do in this problem is we need to maximize the total achievable discount. And apart from this, apart from these n services, we can buy k additional services also. Okay, and uh, the discount. Okay, so the question is saying that if we buy t number of services of same type, then the discount of on that services, the discount on that service will be considered as discount of I multiplied by 2 to the power t minus 1, right? So we will use this particular condition to maximize our total discount. Constraint for this problem is n is up to 10 to the power 5, k is 11, and discount of I is up to 10 to the power 6. Okay, nice. So let's get started with the sample test case. Okay, yeah. Let's take this example where n equals to 3. We are having 3 services. Discount array is given to us. K is 1. We can buy one additional service. Okay, let's see. So as you can see that logical or power of twos are involved in this problem. So there is high chance that this problem is of bit manipulation. So whenever you see this type of operations and these hints, you can try for like binary representation of numbers. Let's see. We are given discount array as 12, 12, 9. So 12 is 1100 in its binary representation again, and 9 is 1001. Okay, so the bitwise OR without like additional buying of any services, the original OR is 1101, right? We need to check whether we can maximize this or not by buying one additional service of type this or this or this, right? Thing is one, right? Okay. So if no additional services to be bought, the discount is OR value of all, right? Which is 13. This is 13. You can check 8, 4, 2, 1. So 1, this is 8, 8 plus 4 plus 1 is 13, right? So this value is 13. Okay. So original discount value is 13. Now we have to choose, like check whether we can maximize this or not. So whenever we buy a service more than once, the discount becomes discount of I into 2 to the power t minus 1, right? We have discussed. Uh, what does that mean in binary representation? Basically, whenever we buy a particular service for t number of times, its discount becomes d of I multiplied by 2 to the power t minus 1. That means its most significant bit gets shifted by t minus 1 times, right? This is an important key observation in this problem, which means uh, not like that. Wait, let me give you another reasoning for this. Uh, Basically, yeah, uh, original discount is just bitwise or, and we need to maximize the uh, maximum. We need to maximize the achievable discount, right? Okay, so to maximize the achievable discount, we need to uh, make its most significant bit as largest as possible, right? Right. So, and let's see with this example. In this example, the most significant bit of the OR value is this, right? We need to increase this. And to increase a more significant bit of OR value, we need to increase the most significant bit of individual service. That means, like with this intuition, you can say that all the K services which we have to additionally buy should be of same type so that we can increase the maximum most significant bit of the OR value, right? This is what I have written over here, which means we have greedily proved that buying all K additional services of one type is more beneficial. Because let's take an example. Let's say uh, take here the first service. Yeah, let's say we are having binary representation of all the service discounts as something like this: 1001, 1010, 0110, and 10. Let's and K is let's say 3. So my claim is, if I am uh, buying all the services of one type only, then the most significant bit of the overall OR value will be maximum. Because let's say if I am distributing this K among all these, let's say I am shifting this most significant by 2, this by 1. So I will be getting new values as 1, 0, 0, 1, 0. Again, this will be 1, 0, 1, 0. This will become 1, 1, 0, 0. And this is 0, 0, 1, 0. So the OR value is 0, 1, 1, 1, 1, right? But instead of distributing this sorry, K among all these services one by one, if I am uh, buying all the K services of one type, let's say of this type, first one, then I can shift this by 3, all these by 0. In that case, uh, the binary representation will become 1, 0, 0, 1, 0, 0, 0. And this will be 1, 0, 1, 0. Third one will be 0, 1, 1, 0. Fourth one will be 0, 0, 1, 0. And overall OR value will be 0, 1, 1, 1, 0, 0, 1, which is way big than the previous one. So that's how you can verify that, or by intuition also you can say that we have to buy all the K services of one type only, right? So now after this observation, we have a question that which service to be chosen to be for additional buy, right? So we have to choose. We have to check for all. Let's now go for brute force solution. For brute force solution, we will be iterating over all the services, and for each service, we will calculate the updated OR value, right? By by taking contribution of all the services except that, and after this, taking the updated contribution of that service, right? So, but this brute force will take us. Uh, Basically, it will be of time complexity big of n square, right? But n is up to 10 to the power 5. So n square will give us TLE. Now we have to think optimally. The one thing in this brute force solution is we have to iterate for each service that is sure. So we have to somehow optimize this thing where we are calculating the OR value. Let's see an optimal approach. So now in this optimal approach, I will discuss uh, a general technique in which whenever, let's see, basically the temporary OR value जो basically the temporary OR value is what? It is the overall OR value, then remove contribution of ith element, add contribution of ith element, the updated ith element, right? Which is the discount of I multiplied by 2 to the power k. That's how you are calculating the temporary OR value. Whenever now, yeah, whenever you have to like remove a contribution of ith index and then update it with something and again add contribution, and again you have to add contribution of that element to the whole value. In this type of cases, you can always use a technique called prefix suffix, in which basically if this is my array, I will be calculating I will build two arrays, prefix and suffix, prefix or and suffix or, where prefix of I will store the or value of all the indexes from 0 to I minus 1, not up to I. I'm storing prefix of I. I'm storing all value from 0 to I minus 1th index in prefix of I, whereas in suffix of I will be storing the OR value from I plus 1th index to n minus 1th index, right? In both of these, I'm not considering the ith index, so that if I have to generate the OR value of whole array, this is just prefix of I or suffix of I and contribution of ith index, and I can modify the contribution of ith index easily. So after pre-computing this prefix and suffix OR in big of n, using both of these arrays, I can create the temporary OR value in big of 1 time complexity. So using this brute force code again, just optimizing this thing, I can write overall code in big of n. So the algorithm for this problem is, firstly I have to build prefix OR, which will take me big of n time complexity and space complexity as well. Secondly, I have to build suffix OR, which will take me big of n time and space complexity. Thirdly, I have to iterate on each service and calculate the total discount, or you can say the temporary OR value, and then just update the maximum value, maximum discount you can get. This step is big of 1. So overall time complexity and space complexity of this code will be big of n. Fine. Let's quickly code this. Hash include bits /tdc++ h using namespace std. I always prefer to use long log instead of integer. I guess make a habit of using long log instead of integer in all the contests and online assessments to avoid garbage values and out of bound errors. Int min. Let's see what is the what is the input format. In input format, first line contains n and k, and second line contains discount array. Okay, let nk. Let's take these n and k as input. Let's create a vector for discount of size n. Let's take it input discount of I, right? Now, after taking input, first step is build prefix or. Let's create prefix and suffix or of size n, right? Prefix or of size n, suffix or of size n. See, firstly I have to build prefix or. So prefix of I is containing the prefix or value till I minus 1th index. So prefix of 0th index will be storing 0 only because I haven't considered any element up till that. So let's start a loop from 1. Prefix or of I is nothing but prefix or of I minus 1 or with the current index, so the current value will be discount of I minus 1 because I have to take a contribution up to I minus 1th index. Now quickly step 2, build suffix or. For suffix or also I have like suffix of I is storing the or value from I plus 1th index to last index. So the n minus 1th index of suffix will be storing 0 because I haven't considered any element yet. So I have to start loop from n minus 2. Suffix of I equals to suffix of I plus 1, and I have to take the discount of I plus 1. Okay, after building this, we have to iterate on each service. Before that, let's initialize the maximum discount as 0, let's say. For each service, temporary sorry, temporary or value is equal to prefix or of I or with suffix or of I, and I need to modify the contribution of ith index, which will become I have to multiply it by 2 to the power k. For 2 to the power k, I can write as 1 left shifted by k. This is also, that's how you can write 2 to the power k using bit manipulation. This is faster than power function. Okay, so this multiplied with discount of I, right? Yeah, max discount equals to max of max discount, comma this temporary or value. After this, you can just return the maximum discount. Let's see whether it runs or not. There is some not declared. Oh, should be capital O. Is running perfectly. Let's quickly submit the code. It is in queue problem. All the test cases are running, so it got accepted. Before going to the next problem, let's quickly summarize this problem again. Basically, what was there in this problem? We are given n services and the total discount is nothing but the OR value of all the elements of discount array, right? And we need to maximize that OR value, right? And to maximize the OR value, we need to maximize the most significant bit of that OR value. And this most significant bit is coming from some individual guy. So that so by intuition, or you can say by verifying, you can say that all the k additional services which we are buying, these should be of same type so that we can maximize the most significant bit. So now after this observation, we got the point that now we have to iterate for each service and we need to calculate the updated OR value by modifying the contribution of ith index, right? By this. But initially in brute force, we have noticed that this particular solution will be of big of n square. Sorry. So to optimize this OR value calculation, we have used prefix and suffix OR in arrays. We have uh, calculated the prefix I up to I minus 1th index and suffix I from I plus 1th index, so that we can easily modify the ith index and add its contribution separately to the whole value, right? And then we have just wrote this code now. We have first built the prefix array, then suffix array, initialized the maximum discount, iterated over all the services, calculated the temporary OR value, and updated the max discount, and this just return the maximum discount. Okay, that's all for this problem. Thanks for watching. Bye.